Alrighty. Number 1, what element is this and how do you know? What do we have? Oscar? Oh, and a complete sentence. This element is? And how do you know? Okay, what did you count to figure out what element it is? Which of these did you count? The protons, neutrons, or electrons? Protons. Good. The positively charged particle. So because there are 1, 2, 3, 4, 5 protons, then this is an element of boron. Okay? According to the table, atomic number 5 is boron. Question?
So he got everything right, but he didn't capitalize or put a period.
Then capitalize it and put a period for him. We're just correcting it. Number 2, what is the symbol for this element? Jacob? It is capital B. If they wrote a lowercase b, go ahead and capitalize it for them. Lowercase b is not an element. Capital B is an element. Yes. Yes, it does. It is. It is B. Subject, verb, predicate. Number 3, how would you make it an ion? How would you make any element an ion, really? Connor? Very good. You would change the number of electrons. You could have more. You could have less. Whoever has Oscars, don't grade that part. He wasn't here for that. Or don't correct it. Whoever has it. You can write in the right answer, though.
AJ.
Change the number of electrons. If they okay, hold on. Back up. There are 3 things you can change in any atom, right? The protons, neutrons, or electrons. If you change the protons, you have a new atom altogether, correct? If I add a proton to this element, to this atom here, you no longer have boron, you have atomic number 6, which is carbon. Okay? If you change the electrons, meaning you either add more or take some away, then you have an ion, either positively or negatively charged, depending on which one is more. If you change the number of neutrons, then you have a what? Raise your hand. Changing the number of electrons gives you an ion. Changing the number of neutrons gives you, Luke, an isotope. That's the answer for number 4. How would you make it an isotope? You would change the number of neutrons. Ryan?
What if you change the protons?
If you change the protons, then you have a totally different atom altogether. You no longer have boron, you have either carbon if you added one, or beryllium if you took one away, things like that. Okay? Alright, number 5. How many energy levels or shells does it have? So looking at this diagram again, you could figure this out one of 2 ways. You could look at the actual drawing and count the shells, or you could look at the periodic table and see what period it's in. How many shells does this have, Oscar? 2. Very good. Here's the first one. Here's the second one. Also, boron is in period or row 2. That would tell you the same thing. And then number 6. How many valence electrons does it have? Jacob? Okay, what's the right answer? How many valence electrons? What? How many? 3. Why, Jacob? Okay, you don't count the shell as full, so what are valence electrons? Where did you find them? Do what? Good. It's the number of electrons on the last shell, or the outer shell. So there are 1, 2, and 3. Okay? Now, hold on, look up here. What if I change the question? What if I change the question to how many electrons total are in the atom? Hold on, focus up here. What if I change the question to how many electrons total are in the atom? Wyatt? There will be 5 electrons total. Good. Only 3 of them are valent, the ones on the outer shell. Okay? All right. You can go ahead and give that back to the person that owns the paper.